This is Mr. Beck Does Your Homework, question number 7. Question 7 says, a light, rigid rod of length 6.13 meters in length rotates in the xy plane about a pivot through the rod's center. Two particles of masses m1 equals 8.1 kilograms and m2 is 2 kilograms are connected to the ends. So this one's 8.1 and this one's 2. Determine the angular momentum of the system about the origin at the instant the speed of each particle is 1.43 meters per second. So I'm going to need the angular momentum of this whole system, and the angular momentum of this system is going to be made up of the angular momentum of each object rotating in that system. So my total angular momentum here is going to be the angular momentum of the first mass plus the angular momentum of the second mass plus the angular momentum of the rod. But as we see in the description, the rod is a light rod. That means that it's not very heavy. That means that it's not going to have any angular momentum. So I'm just going to get rid of that. So really, it's the angular momentum of the two masses that I have to deal with. Now the angular momentum of any mass, no matter how it's distributed, will be the moment of inertia times the angular velocity omega. This is similar to P equals mv, but we say instead of P for the linear momentum equals the mass times the velocity, here we have the angular momentum is the moment of inertia times the angular velocity. So for a point mass, so I'm going to have one and then I'm going to have the other I omega. So for each point mass, the moment of inertia is going to be mr squared times omega. It gives me my momentum plus another mr squared omega. Now what I notice is that the omega is going to be the same for both of these. I know that the r is going to be half of that rod, so that's going to be the same for both of these. So it's just the masses that I have to deal with. So it turns out that my angular momentum total is going to be the sum of the masses times r squared omega. So if I add the masses together, have r squared times omega. Now what is r? In my case, my radius is going to be half the length, in your case too. So the radius is going to be half the length. In my case, my length is 6.13 meters, so it'll be 3.65 meters will be my radius. My omega, here it says the speed of the particle is 1.43 meters per second. But I know that the speed divided by r gives me my omega. Because if I have meters per second and I divide by the radius, then that'll give me how many radiuses I go every second, which is radians per second, which is my omega. Well, now I have to make some substitutions, but if I substitute omega first, you will see that I'm going to get m plus m times r squared times v over r. What's neat about that is that this r will cancel out with one of these. So what I wind up with is even easier. My angular momentum is going to be the sum of the masses times v times r. And here I see that r is L over 2, and I can plug that in there, and I'm all set.